Welcome to PRISCI-ANTO Educational Academy. Find the eigenvalues and eigenvectors of the matrix A is equal to 3 by 3 matrix 1 0 minus 1 1 2 1 2 2 3. So this is the matrix. Let us see how to solve the. So first the characteristic equation, given matrix is so the characteristic equation is the characteristic equation is determinant A minus lambda I is equal to 0, that is lambda cube, because 3 by 3 matrix, minus S1 lambda square plus S2 lambda minus S3, which is equal to 0. So S1 is equal to sum of main diagonal elements. Sum of main diagonal elements. S1 is equal to main or principal or leading diagonal element. So which is equal to, which is the main diagonal element? That is, the main diagonal element is 1 2 3. This is the main diagonal element. So therefore 1 plus 2 plus 3, which is equal to 6. This is main diagonal element. S2 is equal to sum of minus of sum of minor of minus of main diagonal elements. Sum of minors of main diagonal elements. So let us see what are the minors of main diagonal elements. So first, I have written there main diagonal element. 1 is the main diagonal element. So row wise, column wise you have to eliminate. So remaining is 2 1 2 3. This is the minor. So which is equal to 2 1 2 3. This is the first minor. Plus, so next minor of main diagonal element. 2 is the main diagonal element. For 2 row wise, column wise you have to eliminate. So remaining is 1 minus 1 2 3. 1 minus 1 2 3. Plus next main diagonal element is 3. So row wise, column wise you have to eliminate 1 0 1 2. This is the minor of main diagonal element. So if you are simplifying this, you will get, this is a 6 minus 2. So which is equal to 6 minus 2 plus 3 plus 2 plus 2 minus 0. So which is equal to 6 minus 2 4 plus 5 plus 2, which is equal to 11. So S2 is equal to 11. Okay, S2 is equal to 11. Next we have to find S3. So S3 is equal to determinant of the given matrix. S3, which is equal to determinant. So determinant of the given matrix. So if you are finding the determinant value, first you have to write 1 into 6 minus 2. You know how to find the determinant. Second term is 0. So that's why I am not writing. Whatever you are writing, here will be 0. So that's why 3 minus 2 will be 0. Minus 1 into minus 1 into 2 minus 4, which is equal to, so 4 plus 2, which is equal to 6. So therefore S1 is equal to 6, S2 is equal to 11, S3 is equal to 6. So substitute here the characteristic equation. You have to substitute S1, S2, S3 values. So therefore S1 is equal to lambda cube minus S1 lambda square 6 lambda square plus S2 lambda plus S2 lambda. S2 is 11 lambda minus 6 because minus S3 which is equal to 0. So we have to factorize this. If we are factorizing this, first we have to use the trial and error method. Suppose if we are taking lambda is equal to 1, this means 1 cube minus 6 plus lambda 11, lambda is 1 minus 6 which is equal to 0. So lambda is equal to 1 is one of the root. So therefore using the synthetic division, lambda cube coefficient, lambda square coefficient, lambda coefficient minus constant term. Use the synthetic division is 1 0. If you are adding 1 ones are 1 minus 6 plus 1 will be minus 5. Minus 5 into 1 will be minus 5. 11 minus 5 is 6. 6 into 1 will be 6. So it will be 0. So lambda square minus 5 lambda plus 6 is equal to 0. So lambda minus 3 into lambda minus 2 which is equal to 0. So therefore the eigenvalues are lambda is equal to 1, 2, 3. So 3 eigenvalues. So these are the eigenvalues. Next we have to find the eigenvector for each eigenvalue. So therefore to find eigenvector, A minus lambda I into x which is equal to 0. This is the formula. What is A minus lambda I? So that is 1 minus lambda. Okay, with the principal element, with the principal diagonal element, you have to subtract minus lambda. 1 minus lambda, 0 minus 1. 1, 2 minus lambda, 1. Third row is 2, 2, 3 minus lambda. 2 to 3 minus lambda into x1, x2, x3 which is equal to 0. So this is the formula to find the eigen vectors. So next case 1, you have to take case 1 when lambda is equal to 1, because lambda is 3 eigenvectors. When lambda is equal to 1, you have to write, substitute 1 minus lambda. So 1 minus 1, 0 minus 1, 1, 2 minus 1, 1, 2, 2, 3 minus 1 into x1, x2, x3, x1, x2, x3 which is equal to 0. So what is 1 minus 1? That is 0. So therefore 0, 0, 0 minus 1, 1, 1, 1, 2, 2, 2 into x1, x2, x3 which is equal to 0. So if you multiply, you will get 0 x1 plus 0 x2 minus x3 which is equal to 0. x1 plus x2 plus x3 which is equal to 0. Take this equation number 1, equation number 2. Next to 2x1 plus 2x2 plus 2x3 which is equal to 0. Take this equation number 3. Here two equations are identical. Second and third equations are identical. So second and third equations are equal or identical. Are equal or, that means equal means identical. So therefore you have to take from 2 and 3, you have to take only one equation. So first and second or first and third you have to take to find the value of x1, x2, x3. Okay, so I am taking the value of first and second. So therefore x1 divided by x2 divided by x3 divided by. So you have to write like this. First equation I am writing. So first equation is 0, 0, minus 1. The coefficient of x1, x2, x3. Second equation, coefficient of x1, x2, x3 is 1, 1, 1. First 2 you have to repeat. 0, 0. First 2 you have to repeat. So 1, 1 you have to repeat. First one eliminate. Remaining, first you have to multiply this one. 0 ones are 0. Minus of minus 1 will be plus 1. So next to minus 1 minus 0. 0 minus 0. So therefore x1 is equal to, the vector x1 is equal to capital X1, 1 minus 1 0. This is eigenvector for lambda is equal to 1. Next case 2. So case 2 is, when lambda is equal to 2. So when lambda is equal to 2 means minus 1, directly I am writing 0 minus 1. So 1 0 1, 2 2 1. As I told you in the previous case 1, you have to substitute in the formula which is equal to 0. So if you multiply minus x1 plus 0 x2 minus x3 which is equal to 0. Okay. So next one, x1 plus 0 x2 plus x3 which is equal to 0. Third equation, 2x1 plus 2x2 plus x3 which is equal to 0. So equation number 1, equation number 2, equation number 3. From these three equations, first and second equation are identical. First and second equations are equal or identical. So therefore you cannot take these two equations. If you are taking to solve x1, x2, x3, you will get to the values are x1, x2, x3 will be 0. So therefore from 1 and 2 you have to take only one equation, and third equation you have to take to find the value of x1, x2, x3. So therefore I am taking second equation 1 0, coefficient of x1, x2, x3, coefficient of x1, x2, x3. So 2 2 1. First 2 you have to repeat 1 0 2 2. First one you have to eliminate. So next you have to x1 divided by 0 minus 2. Next x2 divided by 1 2s are 2 minus 1. x3 divided by 2 1s are 2 minus 0. So therefore if you simplify this you will get which is equal to x2 is equal to minus 2 1 2. So minus 2 1 2. This is the eigenvector of when lambda is equal to 2. Next case 3. So case 3 is case 3 when lambda is equal to 3. When lambda is equal to 3, the values are, if we are substituting in the formula, minus 2 0 minus 1, 1 minus 1 1, 2 2 0 into x1 x2 x3 which is equal to 0. So therefore minus 2 x1 plus 0 x2 minus x3 which is equal to 0. Take this equation number 1. x1 minus x2 plus x3 which is equal to 0. Take this equation number 2. 2x1 plus 2x2 plus 0x3 which is equal to 0. take this equation number 3. So therefore, now I am going to find the value of x1, x2, x3. So how to find the value? I will tell you. Already as I explained you. Okay. So first two equations, these three equations are not identical, are not equal, different. These three equations are distinct. So first two equations I am taking. The coefficient of x1 in the first equation is minus 2, 0, minus 1. So minus 2, 0. Repeat. You have to repeat. So second equation x1 is 1, x2 is minus 1, x3 is 1. So 1 minus 1 you have to repeat. First one you have to eliminate. So here if you multiply 0 minus 1. Here if you multiply minus 1 plus 2. Here if you multiply 2 minus 0. So therefore in the case 3 x3 eigenvector x3 is equal to minus 1, 2 minus 1, 1, 2. So minus 1, 1, 2. This is x3 value. Minus 1, 1, 2.